we're going to witness medical history. Today, we're going to create Weapon X.
Imagine a world where the boundaries between man and machine blur, where our very essence merges with the most advanced technological wonders. Quantum computing and artificial intelligence aren't just reshaping the digital realm. They promise to revolutionize medicine, offering us unprecedented insights into our own biology. What if, nestled within these entangled qubits and self-learning algorithms, lies the secret to unlocking digital immortality?
Yeah, I think that artificial intelligence will give us the key to genetic immortality. You see, in the coming decades, everyone's going to have their gene sequenced. We'll have billions of genomes of old people, billions of genomes of young people. And what are we going to do with it? We're going to run it through an AI machine to look for the age genes. In other words, the fountain of youth that emperors, kings, and queens lusted over, the fountain of youth will be found by artificial intelligence. Artificial intelligence will identify where these age genes are located. First of all, what is aging? We now know what aging is. Aging is the buildup of errors. That's all aging is, the buildup of genetic errors. This means that cells eventually become slower, sluggish, and they go into senescence, and they die. In fact, that's why we die. We die because of the buildup of mistakes in our genome, in our cellular activity. But you see, in the future, we'll be able to fix those genes with CRISPR-type technologies and perhaps even live forever. And if we cure many of the mistakes that build up in the mitochondria of the cell, we could become immortal.
Throughout history, we've sought a secret to eternal life, often in legends and magical potions. Today, instead of ancient tales, we're turning to the world of technology and the vastness of quantum computing for that secret. As AI dives deeper into the vast ocean of our genetic code, it identifies patterns, mutations, and solutions at a pace previously deemed impossible. Imagine correcting genetic anomalies even before they manifest, or rejuvenating aging cells to their youthful vitality. Quantum computing takes this a step further. With its unparalleled processing power, it simulates complex biological systems, unlocking secrets of aging and disease that have eluded us for centuries. As AI provides the intelligence and quantum computers provide the horsepower, we're inching closer to manipulating life's very essence. There's an enticing promise that one day, through this symbiosis of biology and technology, we could halt, or even reverse, the sands of time. Age could become just a number, and our life stories, instead of concluding, might just evolve into newer, longer chapters. The dream of radically extending lifespan, once the stuff of legends, may find its answer not in magic, but in the marvels of science and technology.
That's the power of quantum computers. And now let's talk about cancer, Parkinson's. Let's talk about Alzheimer's disease. Of course, we now have been able to sequence the DNA of plants, animals, and what can we do with it? Well, not much. First of all, this is how we make the new next wonder drug. Thousands of petri dishes shown here. You put the germ in each one, and then you put a chemical in each petri dish. Hundreds, thousands of them. And then what do? You cross your fingers. You cross your fingers and hope and pray that one of them works and kills a germ. Now, think about it. You just take all sorts of chemicals and then you apply them to germs and cross your fingers and hope that one of them kills the germs. This is how we make wonder drugs. That's why they cost $1 billion. It costs about $1 billion to market one wonder drug. In the future, we'll do it in the memory of a quantum computer. The memory of a quantum computer will now do chemistry. Now, some people say, will this put chemists out of work? Well, chemists who do not use quantum computers will be out of a job. Chemists who do use quantum computers will thrive. That is the future of quantum computers, to be used as a tool for chemists, biologists. And look at Alzheimer's disease. Alzheimer's disease is incurable. And it means that people in their 80s, about 50% of them have dementia. Why? Because of this. That's the protein that gums up the brain. Now we realize, using MRI and other chemical techniques, we now realize that this thing gums up the brain, causing Alzheimer's, but there are two types of this protein. One bends to the right, one bends to the left. It turns out the one that bends to the right kills you. That's why we have problems with Alzheimer's disease. But the one that bends to the left does not. You can have gum all over your brain, amyloid proteins in your brain, and be clear-minded. Why is that? It means there's not a one-to-one correspondence between the protein and Alzheimer's disease. Why? Because only one variety causes it. With quantum computers, in the future, we may be able to separate the left and the right, curing Alzheimer's disease, the disease of the century. And what else can we do with this thing? We can also use it to give unlimited power with fusion. Mother Nature does not use oil and coal for energy. Mother Nature does not use uranium for energy. In fact, the only place in the galaxy that we know of where uranium is used for power is on the planet Earth. What does Mother Nature use? Fusion power. And we're going to create fusion on the Earth. Why has it taken so long to create a fusion reactor? Because of the instability of the plasma, the hydrogen gas. With supercomputers, with quantum computers, we should be able to stabilize the gas to create an operating fusion plant to power the world, to save us from global warming. And what else can we do with this thing? This is the largest atom smasher on the planet Earth, outside Geneva. This is the Large Hadron Collider. What do we do with it? We smash atoms, hoping to recreate the birth of the universe. And how do we model this? With quantum computers. One of the first things we've done now is to put a quantum computer to analyze when two protons are smashed together in order to create a theory of the universe. In other words, the Big Bang, we think, will eventually be decoded by a quantum computer. And hopefully it'll answer the question, why are we here? As I said before, I work in string theory. This is the reason why I got interested in this. String theory is so powerful, but so complicated, that the human mind is incapable of solving it. We think maybe a quantum computer can solve this problem.
As we edge closer to the dream of eternal life, profound ethical dilemmas arise. For millennia, the rhythms of birth, life, and death have shaped human experience and culture. To disrupt this cycle is to venture into uncharted territories of existence. Many argue, just because we can, does it mean we should? There's a deep-rooted cultural wariness. Religious doctrines, philosophical treatises, and age-old myths often warn of the perils of chasing eternity. The fear of overpopulation, resource depletion, and the possible stagnation of societal progress haunt the very notion. But amidst these ethical questions, it's hard to ignore the incredible opportunities quantum computing is bringing to our doorstep. Beyond the quest for longevity, these machines hold the key to addressing some of the world's most pressing challenges. Visualize cleaner energy solutions derived from perfectly simulated atomic reactions or climate models so precise that they enable us to preemptively counter environmental threats. The riddles of dark matter, the mysteries of the deepest ocean trenches, even the nuances of human consciousness, quantum computing could illuminate corners of knowledge previously left in shadows.
And the aging process. Why do we have to die? Well, there's a second law of thermodynamics, which says that in a closed system, everything eventually gets old, falls apart, rusts, corrodes, and dies. In other words, it's a law of physics that you have to die. But there's a loophole. There's a loophole in the laws of physics. Notice that I said that the second law of thermodynamics says that in a closed system, all things must eventually fall apart. The key word is closed. In an open system, where you have energy from the outside, technology from the outside, you can, in principle, stop the aging process. We don't have to die. For example, in a car, where does aging take place in a car? Think about it for a moment. Where does aging take place in your car? The engine. Why is that? That's where you have oxidation. That's where you have combustion. That's where you have moving parts. The engine. Well, what is the engine of a cell? Mitochondria. You now know where aging takes place in your body. You now know why you will eventually die. And then the question is, can we go around the second law of thermodynamics with a quantum computer? By being able to correct the mistakes because of wear and tear. That's how we repair cars. Why can't we repair humans the way we repair cars? Well, maybe we can. And let's say a few things about cancer now. By the time you have a tumor, you have over 1 billion cancer cells growing in your body. In the future, we will do it with a blood test. Already this year, for the first time in world history, a blood test that detects 50 different types of cancers. Up to today, there was no way to tell whether you had cancer or not until you found a tumor or some obvious symptoms. And by then, sometimes it was too late. Now we have a blood test. A simple blood test that can pick up 50 different kinds of cancers. In the future, this will be hooked up to a quantum computer to detect hundreds, maybe thousands of different types of cancers growing in your body. This could be the cure for cancer.
As we're on the edge of big tech changes, the exciting things AI and quantum computers can do are making everyone dream bigger. Throughout history, we've always tried to do more, go further, and find deeper meanings to our lives. But the concept of immortality is no longer relegated to the abstract realms of philosophy or mythology. With AI rapidly deciphering the enigmatic codes of our biology and quantum machines simulating the profound intricacies of life processes, the age-old dreams are morphing into tangible possibilities. Imagine a world where illnesses are predicted and neutralized even before they manifest, where the wear and tear of aging is but a minor inconvenience that technology can swiftly address. With such powerful tech, we need to think carefully. Our stories have always warned us about going too far. Are we chasing this future for the right reasons? While living longer seems amazing, it comes with concerns, like, how will society change? Can we support everyone? And might we lose touch with what makes life special? And then there's a thought even more profound, transcending mere extension of life. As our reality becomes increasingly digital, as memories, experiences, and emotions become data, the line between the organic and the digital starts to disappear. Our very consciousness could one day be encoded, preserved, transcending the physical. As the sun sets on today's technological achievements, a new horizon emerges, hinting at a future beyond our wildest imaginations. But here's the ultimate question. What if, through technology, our aspirations don't just stop at extending human lifespan, but we genuinely step into an era of true digital immortality? While the debate on immortality will continue, there's no denying, the age of quantum computing will usher in an era of unparalleled advancement, challenging and expanding our understanding of the universe and our place within it.
And so I think that we are going to digitize ourselves and give us digital immortality. We'll not only have biologic genetic immortality of some sort, but also digital immortality. And what are we going to do with it? I think we should send it into outer space. If you digitize the human brain and put it on a laser beam and shoot it to the moon, you're on the moon in 1 second. Shoot it to Mars, you're on Mars in 20 minutes. Shoot it to Pluto, you're on Pluto in 8 hours. Think about it for a moment. You can have breakfast in New York, and for a morning snack, vacation on the moon, then zap your way to Mars by noontime, journey through the asteroid belt in the afternoon, and then come back for dinner in New York at night. All in a day's work, at the speed of light. Think about it for a moment. Traveling throughout the universe at the speed of light, downloading your personality into any vehicle you want. Now, let me stick my neck out. So far, everything I've been saying is well within the laws of physics. Well within the laws of physics. Now, let me go outside the laws of physics. I think this already exists. I think outside the Earth, there could be a superhighway, a laser highway of laser porting with billions of souls of aliens zapping their way across the galaxy. Now, let me ask you a question. Are we smart enough to determine whether such a thing exists or not? No, this could exist right outside the orbit of the planet Earth, and we're too stupid in our technology to even prove it or disprove it.